We were looking at the equilibrium concept. Specifically, we solved the problems of equilibrium related to coplanar concurrent force system and the coplanar non-concurrent force system. Right. There is another way of solving the concurrent coplanar, but under some condition. And there is a theorem to be applied. It is called as the Lami's theorem. Okay, there is a specific condition that has to be applied. Only under some condition you can apply Lami's theorem, though it is applicable for the concurrent coplanar force system under equilibrium. Okay, so let's represent using a diagram. Let us say there are three forces acting at a particular point. All right, so let us try to denote the forces in the following fashion. Okay, this is denoted by force F1, this is F2, and a force F3. And let's assume the angles, right? Opposite side of F1, I call that angle between F2 and F3 as alpha. Okay, then opposite of F2, that is F1 and F3, let's call this angle as beta, and opposite of F3, that is between F1 and F2, I say that angle as a gamma. Right, now if at all the force system is under equilibrium, then only Lami's theorem can be applied. There should be, the condition is that there should be exactly three forces, right? Exactly three forces, and they have to be in equilibrium. Okay, right? If all the three forces acting upon a or an object, right? At the center, I'll call it as O. Object O is under equilibrium. Under equilibrium, this is the condition. The condition is F1 divided by the sine of the angle on the other side. Okay, that is sine R should be equal to F2 divided by sine of the angle between other two forces, that is beta, is equal to F3 divided by sine of the angle between the other two, that is F1 and F2, which is gamma. So F1, F divided by the sine, right, of the angle between the other two forces, right, remains a constant. That ratio remains a constant irrespective of whichever force you take, right? So if we find there are three forces acting on a particular point and they are under equilibrium, then only I can apply this. Okay, I cannot apply this to any other system. Okay, now let us try to solve some basic problems. Okay, this is the question. If the following system is equilibrium, find the unknown angles and the forces. Okay, this is the first one. $85 Newton. $135. This is 110 degrees. This is F2, F3, and theta. Right. They mentioned that this particular system is under equilibrium. So whenever they say, yes, the system is under equilibrium, we know that we can apply the we can directly apply the Lami's theorem directly. Okay, let's apply the Lami's theorem. So according to this Lami's theorem, so the 85 Newton divided by the opposite sine of the opposite angle, that is 135 degrees, should be equal to, right, F2 divided by theta. I want to find, but I don't know theta. I can find out, that is 360 minus 135 plus 110. That's the angle. Should be equal to F3 divided by sine of 110 degrees. All right. So we can cross multiply and get the answers, right? If you want to calculate F2, bring this to this side. Similarly, if you want to calculate F3, you can use these two equations. They are equal, right? Either you can use F2 or you can use, right, the original equation to get that. All right. So calculate the values and tell me what is the values you get for F2 and F3. Okay. So F2, if you want to calculate, this is 85 into, okay, there is a sign missing. Please add sign here. This is sine of 360 minus this, right? So sine of 115. Okay, so 85 sine 115 divided by sine of 135. Similarly, F3 is equal to 85 sine of 110 divided by sine of 130. So this implies, what is F2? 100, okay, 280 newtons. F, this is 102.95, right? Okay. This is 92 newtons. Okay. So even using the other methods we can solve, right? Definitely. But this is the easiest. But this is valid only when we have three forces. Okay. Next. Find the unknown forces if they equilibrium. So this is the given. Okay, so there are three forces acting on. One is a T, one is F, and other one is 18 Newton. They have not given any other details. The distances are mentioned over there, right? Horizontal distance is 10 meters, vertically 13 meters. Okay, we are supposed to find out what are the values of T and F. Here they have not given any angles. That's why the lengths have been mentioned, right? Using those lengths, I can calculate this angle theta using a triangle. Okay, so I can see that there is a right angle triangle over here. Using this triangle, I can find out the theta, right? And I can also apply the okay, around a circle, I know that there are 360-degree. I can try to find out the other angles over here. Okay, so there is one angle which is mentioned there. It is 90 degrees. Okay, I know that this is 90. All right, let's try to find out the theta first. So if you want to find this theta, it has to be the tan inverse of opposite. Opposite is 13, adjacent is 10. So 13 by 10. So let's do that. So it is a tan inverse of 1.3. So that comes to be 52.43 degrees. So if theta is that, right, now I can try to write the remaining angles. So if theta is that, so I know that this line is horizontal. So this is 90 degrees. So the angle between 80 Newton and T, right, that can be calculated. Okay, I'll change the color so that we can note this. So this angle I can calculate. That is 90 plus this 52.43. So that is 142.43. So that angle is 142.43. So other one is 90. So that means, yes, I can calculate another angle which is between F and T. So that should be 360 minus this 142.43 minus 90. So that gives me 127.57. All right, so we got all that. Now let's try to write down the equation, because there are three forces and right, it's under equilibrium, so I can apply the Lami's theorem. All right, so that is F divided by sine of 142.43 first force. Take any other force as a second force, that is 18 Newton divided by sine of 127.57 should be equal to the T divided by sine 90. Okay, so let's calculate the T first. So T has to be equal to 80 into sine of 90 degrees divided by sine of 127.57, right? So we'll be able to calculate the T directly from this. So 80 sine 90 divided by sine of 127.57 is equal to 100.93 newtons is T. Okay, so then F can also be similarly calculated. This is 80 into sine of 142.43 divided by sine of 127.57. So this into sine. Right, so this comes to be equal to 61.54 newtons. All right, let's move to the next question. Find the unknown forces in following system. Okay, so this is the given question. We have to repeat our previous problem twice here to find out the unknowns, right? Unknowns could be T1, T2, and T3. Three forces are there, which we need to find out. So, none of the angles have been given, but we can definitely make sure that these two are 90. Okay, so this is 90, this is 90. So when this is given, so a angle of 40 degrees mentioned over here and 35 degrees over here. So they can be used to calculate the other angles. So from the basics, right, we know that if between the two parallel lines, if you draw another line, that is going to hold the same angle. So this is going to be 40. And same thing, you can even apply here. So this is going to be 35. Right? So because of that, now I can say that this angle, right, because this is 90, 90 plus 40, this is 130 degrees. So this total angle should be 90 plus 35. This is 125. Now we can calculate the remaining angle. because it is, I know that total should be 360. You subtract 130 and 90 from it. So this angle is 140. Okay, and this angle, right? I can definitely calculate now. So this is 360 minus 125 minus 90. So this angle is 145. Now, yeah, we know everything. We can directly calculate this. So I know that there are three forces, right, acting at any point. So I'll call this is some T. The same tension will be present from the other side, right? The T value which you calculate will hold good for both the cases. Okay, so for the first system, let's write the Lami's theorem, that is T divided by, sorry, T1 divided by T1 divided by sine 90 is equal to T divided by sine of 130, that is equal to 120 divided by sine of 1, not 1, yeah, sine of 140. So T1 divided by sine 90, T divided by sine 130 equal to 120 divided by sine of 140. Right. Using this, we have to calculate what is T and what is T1. Okay, so let's calculate. Okay, now if I want to calculate T1, that comes to be 186, 186.68. So T, if you want to calculate, this has to be, this is 143.01 Newton. So when I write this for the second one, you can see the same T has to be used, right? So let's try to write that equation for the second time. So this is T divided by, use this system, right? So T is here, so T divided by, now this is sine. I know the value of T, anyway I can write. So let's write the value, because that's the only one force which is known to us now in the second system. So this is T, instead of T I'll write 143.01 divided by sine 125 degrees equal to T2 divided by sine of 90 equals to T3 divided by sine of 145. So using this, I can calculate what is T2 and what is T3. So let's calculate. So T2 is equal to 143.01 divided by sine of 125. Okay, so T2 comes to be 174.58 newtons. And the T3 comes to be 100.13 newton. All right. Now, let us solve another question of very similar type. This is the question. We have to find T1, T2, T3 and T4. Okay, now the angle given is slightly different. So here we can find this angle, right? Assuming that if I try to extend this, then this angle is available for us. Okay, so that from the given angle, I can actually calculate this angle. So this is 25. Similarly, in this case, in the second case also, we can calculate an angle like this. So this angle is 15 degrees. So use them to calculate the total angle. So this is 90 plus 25. Anyway, this is 90. So this is also 90. So 90 plus 25, 115. And this is 15 degrees. So this angle is 90 plus 50, 105. Okay, so that means I can calculate the other angles easily using this. Okay, so this has to be 360 minus 90 minus 115. This is 155 degrees, and this angle has to be 360 minus 90 minus 105. So that is 165. Right? So using this, you can directly calculate by using the formula. So that is T1 divided by sine 90 is equal to 170 divided by sine of 115 is equal to the T2 divided by sine of 155. So using this, I can calculate T1, T2. So that gives T1 equal to 100.88 newtons. Okay, T2 equal to 79.33. Out of this, we can see that the same T2 is applicable even for the second core system which we are. So that is the T2 which we can. So now for the second system, if you try to write, so T2's value is known, so directly we'll write that. So 79.33 divided by sine of 165 degrees should be equal to T3 divided by sine of 90, that is also equal to T4 divided by sine 105 degrees. So using these, the second set of equation, we can calculate what is T3 and what is T4. So T3 is equal to 317.32 newtons. T4 is equal to 304.62 newtons. Yeah. So this is the required answer.